Welcome, everyone. Thank you for joining us today for this virtual workshop on maximizing the use of recycled aggregates for road construction. My name is Paul Shorthouse. I'm the Managing Director of Circular Economy Leadership Canada, and I'll be your co-host for today's workshop. Ask you please to mute yourselves as you come in, and we will give you a chance to unmute and participate a little bit later. But for now, we're just going to kick things off with a bit of background and some presentations to start. Just to give you a little bit more background on the organizers of this event, Circular Economy Leadership Canada is a not-for-profit organization that is working to connect Canada's circular economy community. CELC, we provide thought leadership, technical expertise, and collaborative platforms to help accelerate the systems change and the transition to a low carbon economy and circular economy here in Canada. And one of our key focus areas is on the built environment. So before we kick things off, I'd like to acknowledge that I'm fortunate today to participate from the unceded Coast Salish territory of the Lekwungen speaking peoples in Victoria, BC. And I also want to acknowledge that the attendees that are joining us today are coming from the traditional lands of the Indigenous peoples from across Canada for this event, and we're very fortunate to be able to do so. So for today's workshop, we have partnered with Circular Innovation Council, and it's my pleasure to introduce my co-host, Joanne Saint-Godard from CIC. Joanne is Executive Director at the CIC, which is formerly the Recycling Council of Ontario, and she also leads up Canada's Circular Procurement Centre of Excellence. Joanne, introduce yourself.
Good morning, good afternoon, everybody. Thanks so much, Paul, and thanks to the Circular Economy Leadership Canada for the opportunity to partner with you for this interesting and hopefully fruitful event today. Like Paul, we are also a not-for-profit organization. Many of you may have known myself or my organization previously as the Recycling Council of Ontario, where for about 45 years we really focused on end-of-life management and increasing the value of byproducts and discards to move them through recycling systems and put them back into production cycles. So we're taking all of that 4 decades of knowledge and applying it now to supporting with the CELC the acceleration of Canada's transition from a linear to a circular economy. We are interested in, one of our key pillars of work, as Paul has mentioned, is procurement and using in particular public procurement to create demand for those discards and those materials and to encourage markets to move in new innovative directions that reduces waste and to support low carbon economies. So pleasure to be with you today and excited about the discussion.
Terrific. So we had over 90 people register for this workshop from right across the country, local governments, provincial governments. We had a number of federal agencies, standards bodies, research and academic experts, and many leaders from industry themselves. So I just want to take a moment and invite you to introduce yourselves in the chat box. You can put your names and organizations in there. Great assortment or variety, as I mentioned, of participants and expertise that we can build on from this workshop. One thing you also ask you to do after you've introduced yourself in the chat box is just make sure in your screen where your picture shows up that you revise your name in Zoom to include your first and last name. Some people have come in with a slightly different name based on their link. So this will help Matthias, who's our tech team, support with the breakout group discussions later on. So please make sure to update your name. So as part of our circular built environment workstream that was launched in March of last year, we identified the importance of scaling up the use of recycled materials in infrastructure projects as being really critical to advancing a more circular economy. And really that's the reason for today's workshop. So our objectives for today really are to better understand the economic and environmental benefits that can come from the use of recycled aggregates in infrastructure projects, and in a more specific sense, road construction. We want to understand where the standards of practice are today and where there may be opportunities to go further and harmonize best practices. We really want to understand what the barriers or risks are to moving in that direction that need to be addressed to enable sort of increased usage of recycled aggregates for road construction. And we also want to look at that linkage to procurement as a sort of a key enabler, and the importance of collaboration between the engineering and procurement teams to really help to ensure the opportunities and benefits can be fully maximized. So just looking at our agenda for today, we're going to make it interactive in nature, lots of time for some questions and answers and a breakout discussion. So thanks for joining us and participating. Shortly, we'll get to hear from 6 expert speakers who are going to provide short presentations. That'll include the latest research on the use of recycled aggregate materials for road construction. We'll get a bit of an overview from the NRC on current standards and practices in Canada. Joanne's going to share a little bit more on the role of procurement as a key driver. And we'll get to hear from the City of Toronto as one sort of specific case study in terms of their use of recycled aggregates for road construction projects. So I encourage you to add your comments or questions or links into the chat box throughout the event, and we'll try and capture these as part of a summary document. Make sure that when you're sending in your questions that you select all participants so that they show up and not sent to an individual specifically. And then following our speaker presentations, we're going to have an hour to head off into breakout discussions in smaller groups that will be guided by facilitators to help dig into the opportunities and the issues a little bit further. We'll come back at the end for a bit of a report back and try and wrap up on time at around 3:30 Eastern or 12:30 Pacific. So before we get into the details of our speakers, I'd just like to set the stage a bit for today's workshop by sharing a little bit of background context in order to help develop a sort of level common understanding. I'd start by just sharing a few statistics on the current state of usage of recycled aggregates, in particular from Ontario, since we don't have a great amount of data for Canada as a whole. But in Ontario, just as an example, more than 180 million tons of aggregate are used every year, and less than 7% of the demand right now is met from recycled sources. Municipalities are the largest consumer of aggregates in Ontario, using about 35%. And we're seeing that right across Canada, there's actually quite a wide range of usage of recycled aggregates in road construction. So just in Ontario, for example, some local governments are following the Ontario provincial standard specifications. Others have been developing their own standards for how much recycled aggregates can be used in various sort of layers of road construction, and others that actually prohibit or severely limit its use altogether. This can make it a little bit challenging as a resource to manage in terms of sort of the demand and supply. So we're going to dig into a little bit of that today. This diagram presents really a high-level snapshot that helps to define what we mean by the term recycled aggregates and its primary usage in Canada today. So essentially, recycled aggregates include both recycled concrete material and recycled asphalt pavement. And recycled concrete materials comes in primarily 2 sources, so returned concrete and sort of construction and demolition streams. And returned concrete is the material that's returned to a facility when, for example, a cement mixer has an oversupply from a project, and it's relatively clean in terms of low contamination. The other one, construction and demolition material, is what comes from sort of the recovery of concrete material from buildings or say the bridges or sidewalks or other concrete structures at the end of life. And that C&D stream has a much higher likelihood of being contaminated with other materials like asphalt or even rebar, wood, or gypsum. So the quality issue is something that's very important here. Recycled concrete material is processed, it's crushed, and then it can be used again in infrastructure projects, and largely right now for road base or in backfill in Canada at various levels. But in addition, small amounts of other materials like brick and glass are allowed. And at present, I'd say recycled concrete aggregates are only allowed in very low percentages in ready-mix applications. Lastly, I just say that in respect to the recycled asphalt pavement or the RAP, it's really a growing focus for various road construction applications, including the hot mix and cold mix applications and for road surfaces. But the focus for our workshop today, just to help us sort of keep the scope in check, will be more on the use of recycled concrete material for roads and road-based applications, as this is really some of the low-hanging fruit that we see at present for increasing recycled concrete applications. And there, just a quick flag, there is going to be a separate workshop next month in April focused more on RAP, which we'll share a bit more details about at the end of today's event, and you're welcome to sign up and participate in that one as well. So when we think about road construction, it's really important to consider the various layers and how much recycled aggregate materials can be incorporated into those layers. And in particular, sort of the base and sub-base layers right now is where we're at for the discussion today. And the question that we'd really like to pose with the group is, can today's standards and specifications potentially go further and incorporate greater amounts of recycled concrete materials than what's being allowed today? And that's, we'll dig into that a little bit through the discussions. So what are the benefits for adopting greater use of recycled concrete material, and why should we care? I think three main areas: sort of availability, cost, and environmental. And with respect to availability, we're seeing growing demand for recycling and recovering of valuable sort of resources instead of landfilling those resources. Recycled concrete can be readily available based on construction demolition activities in urban centers or in other locations. Secondly, around cost. So potentially the opportunity exists to get the supplies of recycled concrete at lower cost than virgin sources, given shorter transportation in more urban centers. But of course, this varies a little bit by location or supply. And thirdly, the environmental benefits. So preserving new aggregate supplies and impacts from virgin resource extraction, reducing the materials to landfill, and potentially reducing greenhouse gas emissions based on shorter transportation and processing considerations. So challenges and risks. So it's good to keep in mind sort of the factors that must be front of mind as we start to think about how to maximize the amount of recycled concrete in use. First of all, sort of quality and consistency. So contamination and deleterious materials can create environmental or performance related challenges. On the performance side, so over time, sort of strength, strength when using older recycled concrete aggregates on projects could be an issue, and durability over a longer period of time is an important consideration, with factors like freeze-thaw resistance or drying and wet cycles, for example, over time. Availability and cost, I touched on the last slide, as a benefit. It can also be something as a challenge to manage. So the availability and the distance traveled can affect on cost. Recycled materials may not be available in less urban centers, for example. So there's a bit of a geographic consideration there. And the prescriptive nature of standards is also something to consider. So prescriptive specifications can create issues with maximizing the use, which we'll hear a little bit more about today from Joanne. Really, the alternatives are more sort of outcome or performance-based standards. Sort of lack of consistent approaches. So I touched on this earlier, but the lack of sort of harmonized approaches across local governments or across regions can make it challenging for industry, for example, to invest in the infrastructure and provide sort of consistent supply when demand is somewhat unreliable. And lastly, sort of the perceived risk or the business as usual is something to think about. So how sometimes it can be, a lack of familiarity with using or specifying recycled aggregate in projects, or it could be a previously sort of negative experience that might keep people from wanting to use it in the future. So it's those sort of behavioral shifts to think about as we think about how to shift the way we're doing things and look at the maximum opportunities for recycled aggregate use. So with that, I'm really delighted to have our expert speakers here today, as I mentioned, to help provide much greater insight into this topic than I can, both on the opportunity side and the key considerations. Again, I invite you to send through questions in the chat box during the presentation. We'll try and save a few minutes for those. So without further ado, I'd like to introduce Dr. Leandro Sanchez, who is an associate professor with the Department of Civil Engineering at the University of Ottawa. He's originally from Brazil, but he's one of Canada's leading experts in the use of recycled aggregates, and he's currently based in Geneva, Switzerland on sabbatical, working at one of the world's leading research laboratories focused on this very topic. So thank you very much for joining us after hours, Leandro, and I will pass the floor to you.
Thanks, Paul, for your kind words. I'm gonna try to share my screen. Can you see it properly, Paul? Yes.
Okay. Good. Thank you.
So, good morning or afternoon or even evening, everyone, depending on where you are. My name is Leandro, as Paul mentioned, and I'm going to be presenting to you some of the opportunities we see and the research projects we've developed with the usage of recycled concrete aggregates in new concrete and opportunities to use in roads. So, well, everybody knows that we need to decrease the carbon footprint of construction. So, quick background, in the cement and concrete industry, which is pretty much where I work the most, one of the techniques or the opportunities to try to decrease cement, we have a target of net zero emissions by 2050. So we need to try to accommodate our works in order to be more sustainable. So one of the ways of doing that is through the use of more sustainable aggregates. And whenever we talk about more sustainable use of aggregates, we may talk about the use of recycled concrete aggregates. Now, the use of recycled concrete aggregates, they, as Paul mentioned before, they may reduce the use of virgin aggregate, which is probably a little bit of a less issue in Canada when compared to here in Europe, for example. But definitely over time, we see more and more our natural aggregates being depleted. And also the use of recycled concrete aggregates could reduce the impact of aggregate transportation as well. So it's very important for us to start acknowledging and studying deeper the features of this material to be used, to be able to use that in different applications in construction. So Paul already mentioned a little bit about it. I'm going to go very fast. Whenever we talk about recycled concrete aggregates, we cannot think that all of the RCA, they are kind of the same in quotes animal. So we have majoritarily two types of recycled concrete aggregates, the so-called construction demolition waste and the return concrete. So construction demolition waste is much more heterogeneous. We may have different types of material embedded, such as ceramics, plastic, and things like that. Whereas return concrete is pretty much pure concrete that for some reason does not meet criteria in the field and returns to the concrete unit and is further crushed and reused. But they are very different from one another, right? And we need to understand the features of these two materials in order to be able to apply those in the field. So if we look a little bit at what our neighbors, they are doing in the US, so 65% of RCA is pretty much used as aggregate and base and sub-base of roads. And only 6.5% are used in concrete, in new concrete. If we look at Canadian perspective, and I'm going to go very quickly here because we are going to have other colleagues addressing much better than I do this part, is that RCA is currently used for roads, but not that much, I would say. We can improve it quite a lot. 30 to 5% of asphalt debris are allowed in new base materials. The construction demolition waste, we always need to check for the potential, well, all of the materials that compose that CDW, so that some materials that may harm the concrete or the asphalt might be rejected. But what I would say that to me is the most important feature that should be understood so that we use that with an interesting engineering perspective, it's the unique microstructure of RCA. So if we do a quick look of the microstructure of the RCA, you're going to see that we don't simply have an original virgin aggregate. We have a composition of original virgin aggregate and adherent cement paste or mortar, depending if it's a coarse or fine aggregate. So if you look at this figure here, you may see that all of the particles that are highlighted in the left here in red and in the right here in yellow, you guys can see that I would say that at least 30 to 50% of those particles are not composed of aggregates. They are actually cement paste or mortar. And this should be accounted for, because if this is not accounted, either in the testing of the aggregate itself or in the usage in a new mixture, in a concrete, for example, mixture, we are going to have issues. So I'm going to show, especially in my case, because my research is in this area, the usage of this material in concrete. So normally what people do, people pretty much replace that in concrete, and they use a mixed design that is normally called direct replacement method, or DRM. So they replace conventional or natural aggregates by RCA, either in mass or volume. What is the problem of having that? The problem of having that is that if you compare a companion conventional concrete designed with natural aggregates with a recycled concrete, either, well, both coarse recycled concrete aggregate or fine recycled concrete aggregate, you may figure that the recycled mix will have much less aggregates and a much higher amount of cement paste, because we are not accounting for the adhered mortar and or cement paste. So if you do that, the problem is that with this volumes that are not matched with conventional concrete, we are going to have normally a lower performance. So if you go through papers, reports, past experience, you're going to see that many people, they qualify recycled concrete aggregates as inferior material when compared to natural aggregates. But I've been discussing with a colleague of mine from Natural Research Council, Dr. Reza Fatifazo, and he has a very nice sentence on this. He says, well, it has been good at some point because it has been used, and now is no longer good, right? So it's what we need probably is to find a way of a better usage of this material. And following the works that were developed at NRC in the early 2000s, where a new method of mixed proportioning, the equivalent mortar volume method, has been developed. At the University of Ottawa, we, I would say, upgraded this method with the help of NRC colleagues as well, to develop concrete mixtures with a better fresh state with the use of 100% RCA. So pretty much through that idea that I just mentioned before, so we measured the residual mortar or the residual cement paste in either coarse or fine aggregate particles, and we adopted that and we considered that in the new mixed proportioning of the recycled concrete. So we pretty much matched the volumes of the recycled mix in terms of cement paste and a volumetric amount of aggregates when compared to the conventional mix. And I would like to share with you then a couple of results from this research. The first results are we were very interested in studying the source and quality, the influence of the source and quality in the performance of recycled concrete mixtures. So we used two different types of aggregates, one that we could consider in quotes a stiff aggregate, a quartzite, when compared to a in quotes non-stiff aggregate, a limestone. And we fabricated conventional concrete 25, 35, and 45 made of these two aggregates. We waited, we moist cured those materials for 20 days, and then we crushed those, all of them. So we fabricated, if you wish, 6 different types of recycled concrete aggregates. And then we used the EV method, the method we developed in collaboration with NRC, to proportion 35 megapascal concrete made of different qualities, inner qualities of the RCA. And then the first thing we've done is to measure the residual mortar adhered to the particle. So it's very interesting to see that the higher the strength of the material, the higher the residual mortar attached, which is interesting, especially in the case of the limestone. And the values are very, very high. So the ranges, they varied from 34, 35 to 52%. So imagine that 1/3 to half of the particle is not composed of natural aggregate. So physically speaking, the material is completely different and should be treated differently. Now, we've used the new mixed proportion technique we proposed, and we were able then, whatever was the inner quality of the material received, as long as we matched the values of aggregate and cement paste, the volumes, I would say, we were able to mix proportion concrete mixtures with compressive strengths above and beyond the 35 megapascal that was pretty much the target at the beginning of the project. trying to understand a little bit more durability. And currently I have a big project on this with a PhD student, but in this quick project, we've tested some electrical resistivity on those mixtures, and we verified that they yielded quite good results when compared to conventional concrete as well. So it was very promising, the use of these mixtures designed with the matching volumes from companion conventional concrete. In a second quick project with the same concept, we, instead of using coarse recycled concrete aggregate,
Might have lost Leandro there for a moment.
more, I would say, a scientific approach. There is called a particle packing model. So you can see the green curves here demonstrate the matching volumetric, as I previously mentioned, whereas the dark curves demonstrate the direct replacement, and the blue ones the particle packing. So actually vice versa, the green ones the particle packing and the blue ones the EV. So and we tested freeze-thaw resistance of those. This was actually performance at NRC. And if we compare that, we can see that with the same inner quality of the RCA we received, as long as you mix proportion properly your concrete, you're going to have proper performance. So you're going to have the residual dynamic modulus velocity that is higher than 60% when compared to the initial state. So the loss is lower than 40%. However, if you simply directly replace that in concrete, your material is going to fail over time, right? Because again, once more time, you're not accounting for the higher porosity, higher absorption, and different microstructure of the particles. I just would like to finish by saying that I've been dealing with working at EMPA here in Switzerland, and I've been sharing experiences in the usage of RCA. They use much more RCA than we do, I guess, in North America. They, if they use up until 25% of RCA in concrete mixes, they don't consider even a recycled mix. They consider a conventional concrete. In Zurich, for example, people are almost obliged, I would say, to incorporate recycled concrete aggregate, they can do up until 50% for even structural applications. So I think it's a matter of time worldwide we will need to do that more and more. And I think the opportunities are there. One of the things they are doing as well here a lot is that they are carbonating the aggregates to enhance performance. And the results are very promising too. But nevertheless, this is something that they are doing either with returned, both with returned and construction demolition waste. And finally, I recently discussed with a colleague from ACI and this researcher, because most of my research is with the use of that in concrete, and maybe for roads, people may think, well, but most of our roads are made of asphalt. So how can we transition that use not necessarily on the base and sub-base? And this colleague used recycled concrete aggregate from previously deteriorated RCA. In Canada, we have lots of deterioration due to silica or alkali aggregate reaction. And this aggregate, which normally is no longer used in concrete because we may have a deleterious secondary reaction, had been used in hot mix asphalt. And apparently, whenever used in hot mix asphalt, it yielded very good results, and further deterioration has not been observed. So this might be a potential hot topic for further study in the future with the use of previously deteriorated recycled in new asphalt. So this is pretty much my presentation. Thank you for the opportunity, Paul and colleagues, and I will be open for answering questions if there is any. Thank you.
That's great. Thank you, Alejandro, for the overview and for getting to some of the technical considerations there that I'm sure our engineering audience will appreciate. a couple comments, questions that came into the chat box so far. So a question from Rob around how to define lower performance. You mentioned that earlier in your presentation, Leandro. Do you have any perspective you want to share just on the scale of performance?
Sure. Well, normally the first thing people think about it is the strength, right? But strength is no longer a big deal, I would say, for RCA. We can get whatever the strength we want. However, if you don't match volumetrically speaking the ingredients, as I mentioned before, you need to use lots of cement to come up with a workability and strength required for the vast majority of projects, which makes no sense then with the use of RCA, because we are trying to decrease the carbon footprint with lots of amount of cement. So short answer is that normally the first thing that civil engineers, they think about it is strength, but whenever you are able to match that volumetrically, then we can enhance that word performance to not only strength, but actually a nice workability and much better durability as well, meaning freestyle performance and performance against different types of durability mechanisms.
Great, Rob, hope that answers your question, but if you have any need for clarification, feel free to drop a comment in the chat box there. Doug, you had a comment, I think, that's worth sharing. Did you want to speak to that more specifically in terms of the work you've done to look at ASTM as a test?
Just a small point. We cast concretes 11 years ago now for sidewalks using different proportions of RCA replacing coarse aggregate. And there's absolutely no problem with freeze thaw or scaling or pop outs. But if you do the ASTM freeze thaw test 666A, they fail in about 30 cycles or 50 cycles because it's a dumb test in terms of the preparation. You keep the sample saturated, it never has a chance to dry out. All those pores in the recycled aggregate are saturated. And of course, they're going to be big exploding bombs of turning to ice. So the test needs to be altered to either using procedure B or to allow a period of drying prior to the freeze thaw cycles, I think, to properly evaluate.
I agree with you, Doug, by the way. Yeah, you're right.
I just seem to like a lot of freeze thaw testing at NRC there to show that.
And Doug, for everyone's benefit, you're with the University of Toronto, is that right?
That's right.
Perfect. Joanne, do you want to?
Yeah, sure. I'll help Paul sort of stick handle questions here. So keep them coming. Thanks for that. So Mark is asking any perspective on whether unique microstructure of RCA may have added benefits in road base and sub-base applications.
Well, that's not necessarily my field, base and sub-base applications. I don't see necessarily the unique microstructure as a good point of RCA. It's just a point that should be understood, right? So we are going to have much more absorption. We're going to have a much lower density. So you need to figure out a way of working with that material. Not necessarily it is better than a natural aggregate, but knowing the features of that material, you can find a way to do an engineering solution for this, right? So this is pretty much my point.
There is a related question from Nazir about any studies that sort of have looked at the long-term performance of using recycled concrete aggregate in roadway applications as a sub-base layer. So Leandro, if that's not something you're too close to, there may be others here that could answer that question.
Yes.
Doug or others, any thoughts or studies that you're aware of? And if not, people can always drop them into the chat box, more information or links. Well, thank you very much for your presentation, Leandro. Great overview, and we'll, if you're comfortable with it, we will share out your slides afterwards with the audience.
Sure. Thank you.
Excellent. Okay. So we have a next round of presenters here that will share a little bit more on the opportunity for looking at current standards of practice in Canada related to road construction and the use of recycled aggregates. So I want to introduce, start off with Juan Yedra Cobo, who is the research officer and task lead for the National Research Council of Canada's Transit and Transportation Infrastructure Department. That's part of the Climate Resilient Built Environment Initiative. He's also team lead for the Integrated Urban Solutions at the Construction Research Center, and he has a background in civil and transportation engineering. We have Dr. Omran Madani, who is research officer with expertise in the area of pavement, and Dr. Madani is also a task lead for road projects under the CRBE department. And lastly, Mohammed Shafia is a research officer that's focused more on climate resilient pavement and sustainability of transportation infrastructure. And so with that, I'm delighted to pass it over, I think, to Omran, who will start things off. And I'll stop sharing my screen here. Over to you.
Thank you, everybody there. The title of the presentations is, as you can see there, towards sustainable construction industry as part of the Stakeholder workshop. My name has been mentioned, Omran Madani, and my colleagues Mohammed and Juan are joining me as well. Second slide, Mohammed, I guess. Canada is currently using aggregate faster than it is being made available, resulting in an aggregate shortage. There is for sure there is a critical shortage of natural aggregate and an increasing amount of demolished concrete. Concrete accounted almost for 150 million tons every year as a waste. The current usage of aggregate is not sustainable, and as demonstrated by growing shortage of natural aggregate in urban roads, recycling concrete from deteriorated concrete structures would reduce the negative impact on the environment and increase sustainability of aggregate resources. There are several barriers to overcome in order for RCA to become widely accepted. Initially, there is a high investment in the cost of purchasing concrete crushers. In addition, maintaining those crushers. So there are still many unanswered questions regarding the RCA characteristic and durability, long-term performances on the beneficial use of RCA and RAB in concrete and pavements respectively. Another barrier is there related to the quality of RCA and the cost associated to that compared to the natural aggregate. Concrete industry, including highways, require quality materials that meets engineering, economic, and environmental considerations. However, where high-performance concrete is not required, RCA can be used and virgin aggregate conserved. Next one, Mohammed. Construction, as you see in this slide, and demolishing waste makes up a large portion of all generated solid waste, such as RCA and RAB. The other slide. This slide shows 3% of RCA usage in Ontario in different road structural layers, with 68% in base and sub-base, and 9% hot mix asphalt, 3% in another applications, which is the RAB, and for new concrete, there is a use of 7%, general fill 7%, other applications, it's 6% there. The next one, Mohammed. You can see in this slide, I put some statement there in yellow. That means there is, most of the points here, gap analysis and research work is needed. So you see the RC specification to be used in concrete given in Ontario Provincial Standard Specification 1001, and it is similar to virgin aggregate, similar specification in other provinces. RCA can be used in concrete. There is a CSA and standard ACI mix design procedures to control the fresh and hardened properties. In the same way, using RCA and HMA according to OBSS 1003 and unbound materials according to OBSS 1010 to evaluate different properties. Okay, can we go to the other slide, Mohammed? Same things here, optimization of concrete mixtures. We need to do some gap analysis and research work to extend like the limitations there being set by some standards there. So as you can see here, both CSA and ACBA allows use of RCA as long as the resulting product meets its performance standards. Both CSA and ACBA criteria were used as a guidelines for optimizing the concrete mixture to improve both fresh and hardened concrete properties. Next slide, Mohammed. First, using RCA in concrete, the Canadian Standards Association addresses RCA very loosely due to ambiguous characterizations of the product in the national, provincial, and municipal material standards and building codes, all of this imposing severe restriction of using RCA. For instance here, 75% of all concrete used globally is non-structural, which begs the question, why are we using structural grade aggregates to produce non-structural concrete? I believe research work is needed to support the changes. Also, as a material, for instance, OBSS indicates some limitations using RCA and RAB in some materials. For instance, here, granular material O and granular material 2, there are some limitations that can be increased with doing some research work. Also, one of the performance parameters here, it is the Los Angeles separation test, and there is a limitations there. This one can be better evaluation of this tool to see how can we increase the limitations here with having a good quality of RCA being adopted and used in concrete or roads. The other one, Mohammed? There are some practices being used now. For instance, here, the best practice guide for recycling aggregate for Greater Toronto area, roughly explaining whatever mentioned in OBSS 1010 from quality control, production, environmental compliance, and safety issues as well. Ontario Good Roads Association will be unveiled the reclaimed asphalt best practice guide spring 2022 with more explanations there. How can we stockpiling RCA, preventing it from contaminations, and also better management of the stockpiling there. Also, the processing operations there, what should be considered. I think, Mohammed, I leave the floor for you for the second part.
Thank you very much. Hello, everyone. This is Mohammed. I'm glad for the opportunity today. So in the next few slides, I'll talk about some of the needs for future research. And I also thank Leonardo for discussing some of his basically collaboration with NRC that is ongoing on recycled concrete. So I'll start with some highlights from Infra Guide 11, which was published in 2005 in collaboration between NRC and the Federation of Canadian Municipalities. I know most of you are already familiar with this. So some of the lessons learned from this guideline mentions that use of RAP as a granular base obviously reduces the amount of new granular material which is required for road construction. However, we might agree that the value of the asphalt cement in the RAP, which is basically the binding agent, and the amount of energy which was invested to produce this may not be fully exploited if that RAP is only used within the base layer. However, there are some circumstances that really dictate only using the RAP in the base layer. We all, I think, agree on that. Also, there are some particular benefits according to this guideline for using processed RCM in subbase, especially in urban areas, because of the cost saving and economic aspects of it, due to reducing the cost for transportation and the supply. Also, some of the highlights from the NSHARP report 598, which was basically sponsored by the National Cooperative Highway Research Program in the US. It indicated that there are some in unbound layers. However, they also highlighted some constructability concerns and the validity of the standard test that we also discussed about some of these issues during the previous presentation during the Q&A session. So some of these issues can be also related to properties of the aged asphalt binder, presence of contaminants like soil, mud, which are not usually found in the virgin aggregates, but they are somehow common in the recycled aggregates. And also we all agree that these materials have been exposed for a long time to different environmental elements such as aging and climatic factors. As a suggestion from NSHARP report 598, using accelerated pavement testing or in-service testing of the pavements is considered as two potential basically research that can help evaluate the potential of these materials, evaluating the pavement designs that are based on these materials, and some other performance related features, which was also brought up during the Q&A a few minutes ago, how performance can be measured. So if we talk about like these two technologies, one of them being the accelerated pavement testing, here you can see the top picture, which is a circular test track in France, and also like another type of accelerated pavement testing using some heavy vehicle simulators, HVS. This one is from Federal Aviation Administration, again in the US. Using the accelerated testing can provide us with a quick evaluation of both flexible and rigid pavements, which are built with unbound recycled aggregate layers. These technologies can also provide us with the effect of multiple factors, control factors, such as, for example, using a specific type of aggregate with specific properties and how the performance of these unbound layers can be measured with proper visual observation or instrumentation. There are some shortcomings of APT, which probably is known to everyone. It's the long-term evaluation, because the long-term impacts of freeze and thaw during multiple years, the strength loss associated with these long-term impacts may not be fully investigated using APT technologies. However, we all know the value of in-service test pavement. These are like full-scale real projects, which are most of the time instrumented with basically strain gauges, soil compression gauges, earth pressure cells, as well as some environmental sensors such as time domain reflectometer, moisture sensors, temperature probes, settlement plates, so on and so forth. So with these in-service pavement testing, researchers and practitioners can evaluate the actual performance of roads built with recycled aggregates. And especially if you have multiple test sites across the country, we can evaluate how climatic variation can impact the performance of these recycled layers. So construction procedures can be also simulated in this way, and that's also good for contractors' experience, and also updating the construction standards and the specifications especially. And as I mentioned earlier, instrumentation can be a key tool to give us exact in situ results of how these layers are performing against traffic loads and environmental variation, so that we can have like a mechanistic design of pavements using the results of stress, strain, and deformation measured from these gauges. Here you can see, for example, one controlled vehicle testing, which was done in Edmonton, Alberta, using a known weight truck passing over the sensors. So with this technology, or having like continuous truck traffic, we can measure the overall performance of these layers using instrumentation. So I'll again pass it to my colleague Omran to wrap up the presentation with some conclusion items.
Recycled RCA is a readily available, flexible, and sustainable product that has a proven track record as a high performance materials for base, sub-base, and other construction projects. It is also viable substitute for virgin aggregate and concrete for an increasing number of applications. Committed to increasing the use of recycled aggregates by continuously reviewing policies, benchmarking with other municipalities, and conducting research to identify best practices. This ensures that we are upholding and executing environmentally and friendly practices. As Mohammed said, the instrumentation will be one part of the work, and that is proven by the literature review, provides and offer a view of sustainability and key performances indicators. The material properties of RCA and RAB, both as aggregate and in concrete mixtures, HMA, and proportioning design with RCA, performance of existing RCA pavements, and the implementations of RCA, highlighting that the RCA has been used successfully and more work needs to be done. Using this with concrete as RCA and RAB conserves virgin aggregate, reduces the impact on landfills, decreases energy consumptions, and can provide cost saving. However, there are still many unanswered questions on the beneficial use of RCA and RAB in concrete and pavement that will require laboratory and field investigations. NRC can help with revisiting different recycling policies. The last one, Mohammed. Thank you.
Thank you, Mohammed. Thank you, Omran, for providing that overview and sharing the slides around standards, practice, and testing considerations. Had some good questions come in through the chat box. Joanne, do you want to?
Yeah, I can help you again navigate some of these. So this one appears to have come through from someone named Marion, but we know we have several Marions that have come through on that name. So, but it's a simple question with respect to, and I think this is kind of the heart of what we're getting into in the latter part of today's workshop, which is the certifications and the standardization of this practice. And so the simple question is, is there a certification right now for the use of RCA? So if our team at NRC, I know there is some sort of provincial standards that you spoke to very directly in your PowerPoints, but are you seeing any certifications where that's concerned, third party or otherwise?
We at NRC here, we do research work, and we will both. So we don't certify anything here. We don't. We can help, like as you said, the industry, how to do things and what can be done, and what is the percentage of RCA, what is the properties that you are expecting if you use this kind of RCA versus the other versus virgin aggregate. And yes, we can improve the properties, the fresh properties, the hardened properties, but to standard to issue certificate, no, we at NRC we are not allowed to do this.
Okay.
Anyone has thoughts from the audience here in terms of certification or other considerations there? Feel free to jump in with a comment, or you can put something into the chat box if that helps. There is a related question from Tim, and then I'll go back to an earlier question. The question from Tim comes around, again, the issue around quality control. And we've heard that a little bit in preparing for this workshop and in speaking with others. There's some concern that you get concrete piles of returned concrete or construction demolition waste that pile up, and there hasn't been enough quality control with those piles of concrete to ensure the performance or the quality is there at the end of the day. And that's been a bit of a barrier for some to using it. There's maybe a lack of a trust or an issue there around quality. So any reflections, Omran or Mohammed or Juan, in terms of whether the NRC has worked at all with industry to help improve the quality control side of things?
Juan, I think you can answer this question regarding how you're collaborating with different municipalities. You want to take that?
Yes, sure. This is a case-by-case situation. Really, conditions vary a lot from not only from provinces but also from different locations. We are working with some municipalities, and we are trying to improve not only quality on the source of materials or supply, but also on the performance and the final product. So those two aspects are important. If for some reason the aggregate that is being used is of a little lower quality, it can be compensated by the design. And what we are trying to do is to produce a result that will be acceptable and within some performance index. So as far as we understand, the industry is going towards performance index, and that is what is more like industry is more interested at the moment.
I think it has been flagged, though, just raised in speaking with industry associations and others, that it has been a key issue that has been a focus of the supply side in the last little while, and trying to get better management practices in place. So with testing, et cetera, it may be less of an issue going forward, ideally. But we will dig into that a little bit as part of the breakout discussions, because quality is such an important topic. Just to keep us on time, there was a question from Reg here about RAP in the granular road base, and whether it may be considered a contaminated soil if removed at some point in the future, which could add cost to future construction. So is there a risk with using RAP in those base layers that it could be a contamination factor that would, for a local government or others, add cost down the road? Any thoughts on that from the NRC's perspective? Are you looking at the leachate or risk around RAP use in subbase, for example?
Omran, you want to go
ahead?
ahead?
I can talk here. There is some studies being done there. As I told you there, we need to do some gap analysis and see. This can be performed there to determine, but the aging factor of the RAP, that will affect the amount of chemicals available there. So I guess we need to do some work there and to determine what kind of chemical is there, residual chemical is there in the RAP there, and how that can penetrate to and try to contaminate the water table in case if it is there. If it is like still in the stockpiling there, that's another issue as well. But there is a study being done and proving there the contamination impact is very, very small. So negligible. So as I said, we can prove that, and that has to be done by doing some testing.
Thanks, Omran.
Yeah.
So I'm hearing negligible, but more work to be done. I do know there's some research underway on the RAP side in terms of its risk. But just before we go to a short break here, there's one last question for the NRC, and that's just people would like to understand the research topics that NRC are currently focused on with respect to RAP and RCA. Would you be able to speak just at a high level in the next 30 seconds on NRC's current research in this space?
Yeah, I guess the speakers before me from ATOU there, he did talk about collaboration project between NRC and ATOU, and I was part of that project, helping my colleagues there. I think we can expand that work, and we can consider road applications using increasing the limitations of the RAB and the base and sub-base, and also try to expand the limitations in HMA using both RCA and RAB.
Okay, thank you. I will. Why don't we take a break here? We've been going for a little bit with the presentations, and we've got a couple more very interesting speakers coming up next, but we'll take maybe a 7 or 8 minute break and come back at about 20 to the hour, and give you a chance just to refresh coffees and catch up on anything. And there may be another question from Ahmed when we come back, so we can jump to that one as well. I'll also ask for anybody that hasn't renamed themselves and you're showing up as Marion in your screen, if you could do that on the break, that would be great. You just click the 3 little dots in the top right corner of your picture, and that'll allow you to rename yourself. That will help with us in the breakout portion. Thanks. So we'll see you in about 7 minutes.
Thank you, Paul. Bye.
Thank you for staying with us as we dive into the second portion of today's workshop. And before I introduce Joanne, I know there was an outstanding question that Ahmed would like to ask the group here. And Ahmed, I didn't see your question in the chat box, so if you're comfortable unmuting yourself and turning on your camera, feel free to ask the question directly.
Sure. Hi. Thank you, and thanks, Omran and Muhammad, for your presentation. I just have a quick question regarding if you guys aware of any environmental study that done on using the RAB or the recycled concrete or RAS in either in the concrete or in base on sub-base material like a road, and if those environmental study taking into account the expected shortage in the surface life due to using the recycled material and the high deterioration rate in the concrete in this case, and is going to be environmental by the end of the surface life of this concrete or not. Just like I'm wondering if you guys have done any study regarding this, or you see any study regarding this.
May have to. Omran, did you catch that? No, maybe not.
Yeah,
Hello.
He's talking about the environmental impact if we done any work in concrete using recyclable aggregates. Is that what it is?
Yes, I'm talking about, yeah, we understand that it's environmentally to use recycled material. I'm more talking about what is the impact of using the material on environment, and if those study consider all the shortage in the surface life for the material for the road, for example, if we use this material road and or not.
If I understand your question again, so I'm not sure if you can repeat the question again there, because I couldn't understand that, please.
Ahmed, maybe it'd be easiest if you want to just summarize it in the chat box, and then
Okay.
we can respond that way and make sure we can follow up. Okay, that's great. Thank you for that. Okay, with our next round of presentations, we have Joanne Sengodar, as introduced earlier, the Executive Director of Circular Innovation Council, and her expertise has focused on the development of policies, programs, and practices that help to advance the circular economy and drive positive environmental outcomes with market-based approaches. And she's been looking at procurement as a key driver there. So Joanne, I will pass it over to you and let you take over the screen share.
Okay, that's great. Let's hope I can do this. Properly. Am I all set up?
You're good. We're seeing, you can go into presentation mode and we're good to go.
Okay, that's great. I'm hoping that you can hear me and the PowerPoint's working okay.
Yes, we're good to go.
Excellent. Okay, so I'm going to take the conversation sort of in a little bit of a left turn, and I'm very, very mindful that we've got a lot of engineers and engineer minds in the workshop today. So we're very grateful for the technical discussion that we've had thus far, and it's absolutely needed. But where I'm trying to sort of take you in this presentation is the intersection to what currently seems to be sporadic or inconsistent use of recycled aggregate thus far, and entertain this idea of, can we start to standardize it and maybe even certify it, as has been suggested in one of the questions today? And then how do we intersect that with more broadly, more sustained and more systemic use in public procurement and buying of the construction services? So I'm going to talk a little bit about where, there we go, next slide. I'll just get right into it. So in terms of sort of why we're doing this and what's the difference between sort of the linear economy and the circular economy, just to give you a bit of background drop in how we are consuming differently and what this means. It's really around this idea of maintaining aggregate and materials in general at the highest utility and value at all times. So that's the overarching environmental reason we want to do this, and why we're looking for mechanisms in order to reduce virgin materials with recycled aggregate. And I think we always have to continually bear that in mind. And so the circular business model that we're trying to employ here is, of course, resource recovery, acquiring additional use and value from existing resources, and of course, avoiding disposal by doing that. And most importantly, the impacts that come with new extraction. So with that in mind, why procurement, and why do we want to switch to circular procurement? And what does that actually mean? The definition of circular procurement is goods and services that are purchased systematically and purposefully to incorporate closed energy and material loops within value and supply chains to reduce waste and other environmental impacts. And a call out was already made today in terms of the ability to, by Dr. Sanchez, I believe, the importance and the connection between low carbon building. And so how is circular procurement different from regular procurement? Well, it's really in focusing on outcomes rather than specifications. So this departure from what's been really a specification-based conversation thus today. But why are we focusing on public procurement in particular, and picking on governments as it relates to this opportunity? And it's really because there's enormous buying power that rests with governments, and you can't have circular supplies if you don't have circular buyers. And so when we look at the value of public procurement in the Canadian context, it actually represents now more than 15% of our total GDP, with a current value of $200 billion. So when you think about starting to make this a common practice by standardizing this across the country and really shifting the market to prefer recycled aggregate or maximize its use, really the government procurement purse has an enormous opportunity. Coupled with that is their social public policy commitments and agendas around carbon emissions, waste reduction, supporting local business and local economic growth. So often these practices don't get tied into the broader commitments of governments. In particular, now we're seeing municipalities make them on a community-based level. So when we talk about the influences of public procurement, certainly the direct spending on goods and services, but their ability to enable market transitions to stimulate the economy in a certain direction is often untapped or underutilized. They also are funders or influencers of other organizations, in particular where we have private and public entities working towards a common good. And so their role in advancing best practices and developing those markets and training and employment, and you can see the interest with NRC and the influences and investments being made at their level, is really, really important. So when we think about, where is the buying power within governments, 80% of all public procurement are about a value, an estimated value of about $160 billion annually rests with the municipal sector. So really great that we have such municipal representation today, because really at the end of the day, that's where the big public dollars go as it relates, particularly with construction. A lot of opportunities for municipalities, interestingly enough, to drive this agenda. And again, this connection to now more than 500 municipalities across the nation declaring a climate emergency, and many of them within that now have new circular economic ambitions that they are making public. And the flip side of that is that they are actually the ones that are directly managing the damage that's created by living under a linear economy. The weather events, the waste and pollutions are often managed and at a cost at the municipal level. And because of their buying power and market influence, they are certainly considered the hub of the Canadian economy and strong incubators and catalysts for change. So we really see that the municipalities have a really important role to play and can be front and center with respect to making the use of recycled aggregates more common. And when we look particularly, and I'm picking on the city of Toronto here, so welcome to our friends from the city that are from Toronto that are here, you see that construction and infrastructure is by far the largest by way of percentage and dollar amount with respect to the common spending categories of municipalities. And so going back to that common theme of market influences. So Paul touched on this in his opening, talking about, why do we do this? Who cares? What are the benefits of moving to maximize the use of recycled aggregates? I think we've touched often enough on the environmental benefits, but when you look at the economic side and the social side, those are often not at least voiced or recognized. On the economic side, we talked about reduced costs, using local employment by utilizing local material as opposed to going to source virgin, and those innovations that are stimulated from that. And then improved fiscal responsibility and economic growth. So really, this is material that we want to use on site, and we don't want to be transporting it from faraway places. And so the economic benefits that come from that application, and then the local employment opportunities and those important public and private partnerships that are really at the heart of innovations. I wanted to have a placeholder for this slide in particular, because I don't think there's enough connectivity here around the opportunity to maximize recycled aggregate and its ability to actually provide this low carbon solution. Often when we think about carbon emissions or GHG, we think of out of pipe, or we think of building emissions, but we know that in order for us to hit the targets that we have all committed to in Canada, or even at a local level, we need to get at the embedded carbon that is part of the goods and services, and in particular construction. So when we think about scope 3 or embedded, we can see that in fact there are three real direct abilities here through the purchasing of recycled aggregate or its reuse, the transportation that would be reduced, and the distribution by looking at local applications, and then of course avoiding those wastes generated. And so I think what we want to do, in addition to trying to standardize and maximizing this use, is actually tracking it. We've already stated that there's a need for better data, better reporting, and certainly as it relates to maximizing recycled aggregate and then accounting that in our carbon emission reduction targets is going to be really important. So I think what we want to talk about, and again, it's been touched on several times in the previous PowerPoints today or presentations today, is this idea of moving from a prescription or a specified specifications to more outcomes-based. We've talked about the need for recognizing that, that the recipe changes as it relates to mixing in recycled aggregate. But really what we're trying to drive here is a certain outcome to make sure that we minimize our risks, that we're meeting quality control issues, that we level the playing field for the procurers and the suppliers alike around driving outcomes, low waste, low carbon, and of course, meeting the specs that are required. We want to look at standardizing testing and reducing those barriers that are driven through a common standard. And then by doing so, improve the compliance and the increased usage. So, I think the industry is prepared to sort of meet the specifications, but need the flexibility to be able to deal with the local variations that have been discussed again in the conversations today, and the abilities for a more outcomes-based standard to do that. So really the questions around, how can we connect these discussions around specs and standards to more use in procurement? What is the role, or what might be the role, of national standards on recycled aggregate in having maximized the public procurement opportunity? How do we actually have the engineering functions connect better with, or more directly with, the public procurement functions of governments, in particular municipalities, in order to move the markets in this direction? And then by extension, what are the supports that procurement functions actually need to implement such a standard? And we realize that there's several pressures on procurement, certainly timing, and they are certainly a risk-averse function within many governments. And so what do we need to have the engineering functions, the construction functions of governments work with procurement, again, to work with suppliers to maximize the use of RCA. So that's just a touch point into procurement. I'm happy to take questions or comments as they may come up. And thanks for the opportunity, Paul, to just provide some thoughts around the use of government procurement.
Thank you, Joanne. That was really good to sort of make that connection and maybe have people think a little bit about, what are the outcomes we're really trying to achieve, and how do we design our specifications or our procurement documents, for example, to drive that sort of outcome that everyone's looking for. I don't have a question for you, but lots of good comments in the chat box. The question that maybe I'll just pose to you before we go to a case study as one example is, what are some, are you aware of an example or two where the engineering teams have been working in the construction space with procurement to really look at those outcome-based approaches? Are there a couple of
and I think we have got a couple of those champions in the room today. I know that the city of Richmond in particular has been really making commitments towards integrating circular procurement. And I know we have Marcos on the line with us today, and they are finding new ways to work with their procurement functions more closely. We're going to hear from the city of Toronto next, who's really been a champion, as I understand it, utilizing RCA. So, I think it's about trying to de-risk the issue and to help procurement meet the market where it's at, and then advance the market, moving forward. And often we know that if they've got a guideline, a standard, even would be better, that they can hardwire into the procurement RFPs, RFIs, the tenders. Then it helps them to de-risk and really level set the market. But I don't think, we've seen allowances, I think, in guidelines. I know the provincial standard in Ontario in particular has an allowance, but that doesn't necessarily allow us to maximize the use. So we want to look at, how do we transition those allowances into more of an outcomes based, where if we can meet the strength specifications, the durability specifications that have been talked about today, but maximizing those materials, what's the sweet spot in that, and what that standard could do, and how do we bake that into procurement practices?
Terrific. Okay, thank you. So So I'm going to share my screen again here and introduce our final speaker for the workshop today before we head into sort of some roll our sleeves up a little bit and get into some of the questions as a group. Robert Klimas is the senior engineer with the Engineering Construction Services at the City of Toronto, and he has extensive management experience in leading interdivisional groups, creating and updating and maintaining 25 sewer and water main and over 40 roadwork constructions and various material specifications. So we're delighted to have Rob from the City of Toronto share a little bit on his work in this space, and I will share your slides on your behalf, Rob. So
okay, thank you, Paul.
You bet. All right. Can you see those?
Yep. Okay. Okay, thanks everyone. Thanks, Paul. So I'm going to talk about the study we did back in 2016 about using reclaimed concrete material. Next slide. So we wanted to, back, I guess in 2010, we had like a motherhood statement that we should use, recycled materials in our construction activities, but it was just a motherhood statement, special provision in our contract documents, but it wasn't really, there were some concerns about using it. So some of the concerns raised were that it may not be equivalent to natural sand and gravel, apparent low strength. There was a spongy appearance. There was concerns about failure or heaving, aggregate breakdown, low permeability, and just consultants not comfortable designing and specifying these materials. Same with our inspection staff and designers. Next slide. So the project was into 3 phases. One was like a desktop study of our current practices and city issues, sampling and testing an actual stockpile from one of our suppliers, and then updating our specs and design guidelines. And then we also provided training to about 250 odd staff at the lab to show them what RCM looks like when it's mixed in with granulate and what to look for. So the first phase was the desktop study. So we reviewed the past City of Toronto experiences with RCM. We did a specification review, and then we made recommendations. Next. So at that time, there was an instance on Highway 427 north of Finch where they had used RCM in the shoulder, but it was mixed in with drywall or gypsum. And what you could see here, like you can see, it's very spongy. So they had to remove it. Next slide. And so while they were removing the shoulder, they noticed that the pavement was starting to heave. So next slide. So when the granular is mixed in with gypsum drywall, it starts to heave, but not like our regular heave thaw cycles where pavement rises and goes back down. If there's gypsum in there, it starts heaving and just continuously starts to heave. So what they had to do here on the 427th was actually grind that all off and put a whole new subbase and pavement. So that's where all that media hype about was RCM not good. So there's 3 sources of, there's RCM class 1, which is kind of like concrete from runways, rejected pipes. Class 2 is non-structural stuff like sidewalks, curbs, and gutters. And class 3 is sort of like construction and demolition waste from buildings and cinder blocks. Next slide. So we did staff surveys, and the typical comments were about excessive wrap and soil. They were silty. We noticed that some of the RCM was fine. There was a lot of fine sandy silt had low bearing strength. We noticed on one project there was on post-construction heaving, differential heaving, and people thought maybe would the wrap affect the gaskets in the PVC pipe. Next slide. So we reviewed our specifications, TS 1010, which is really an it's an amendment to OPS 1010. And we came up with this special provision GN 124. And so we created the spec. We ran it for 2-3 years. The way we do it in Toronto, we run it for 2-3 years and work out the bugs. And then we incorporate that into our specification and then cancel the special provision. So we added requirements for granular array RCM, granular array wrap, and 50 millimeter crushed aggregate. Next slide. So the specification review. So with granular array, we allowed up to 100% RCM, and then we allow also we call it granular array wrap, where we allow up to 50%. Sorry, not 50, 30% wrap. We also don't allow no glass or ceramic material. And then deleterious material max 0.5%. I think the OPS is 1% max. We narrowed it down to 0.5. And we added that no gypsum plasterboard wall board mix could be used. Next slide. So the recommendations from the study was we're doing testing for water-soluble sulfate concentration, so that will see if there's any gypsum. We want the contractors to provide a quality control plan. We want to demonstrate the control of sources. And we want the contractors to guarantee that no construction and demolition material is used. We'll go into that a bit later. So the next part of the phase of the study was we actually went to inspect the stockpiles at the supplier down on Commissioner Street. And so you could see we note if there's any the type of material, delirious material, what type of material. And actually overall, the stockpiles they had were pretty clean. They just contained curb, gutter, sidewalks, building foundations, and gravel, and maybe some rebar. Next slide. So what we did was we inspected the RCM that was produced. There was negligible amounts of any foreign material. Any metal was removed, and you could see there was a high angle of friction. So it was a good stock, good material and practices they were doing there. Next slide. So on the side, we sampled the material according to MTO LS 625, where you take 3 bucket loads from a front end loader, you mix it back and forth with a blade about 300 to 500 millimeters thick, and you take a sample at 3 separate locations with an approved spade. Next slide. So we did some testing on it and to see if they conform with TS 1010, and we did a full physical suite of other chemical tests. I don't have the results on these slides, but they can be made available. We did a sulfate risk assessment on the stuff, and we compared it against virgin aggregates. Next slide. So, what we found was that the stockpile material found had a low risk of sulfates, so which was good. They were keeping gypsum out. Results range from 720 to 1100 micrograms per gram. One test was kind of high, moderate risk, and that kind of just showed the importance of controlling the stockpile. Next slide. So some of the concerns about using RCM in trenches as a pipe bedding and trench backfill, there was concerns about the PHCs and PAWs present in wrap, which could leach and damage other rubber gaskets. There was a concern about tufa precipitates that could clog the drains. and also about the pH of the leachate, which could affect some water resources and fish habitat. Next slide. So what we found was the RAP was considered to be chemically stable. But just to be on the safe side, we're not going to allow it in the trench bed. We'll allow it in the road base. So we added granular RCM to TS1010. That we found that TUFA was not an issue based on the city and research done to date. pH still required some research, but the research showed that the initial spike in pH was fairly normalized after a few hours. And then also RCM could be corrosive to some metals like galvanized and aluminum piping. Well, we don't use aluminum piping in our road network, but we could use galvanized where we're using like for driveway culverts. Next slide. And one of the key thing was about a contractor supplying a QC plan. So key elements were controlling the source during delivery, detailing a detailed description of the process, how to remove deleterious material, and how gypsum and plaster are kept out. Next slide. Next slide. And also about the QC plan, show how the physical properties were evaluated for sulfates. And we asked them to provide a written certificate. I guess here's that thing about certificates we talked about earlier in the sessions, stating that no construction or demolition waste have been used into production. Next slide. So in conclusion, we found the RCM in the cave generally meets city specifications. There's similar properties to virgin materials. The physical and mechanical properties were observed were vary, but sometimes considerable between projects. And this confirmed the need for a contractor to have a quality control plan and the city to do quality assurance. Next slide. And the last part of the project was to update our city standards. So the main focus was that we were going to use RCM without RAP for pipe bedding and backfill. Aluminum galvanized piping should not be used with RCM. We should do sulfate testing and begin requesting contractor to do a quality control and also complete physical testing in accordance with our new spec TS1010. Next slide. And like I said, we updated our TS1010. So in the beginning, it was just granular A, which meant, just from the quarry virgin material. So we still allow so we changed it to granular A native, which means quarried material, granular A RCM, which could be used for trench bedding material, granular A RAP, which could be used for the road base, and 50 millimeter crushed aggregate. So our default is for our trenches and everything is granular A RCM. So when we put that on our engineering profile drawings and go out to tender, that's the default is granular A RCM. Next slide. And the Aggregate Recycling Ontario, they created a bunch of standards for producing quality aggregates. And they were kind of committed at the time to produce quality aggregates. And so they have a best practices their guide under the auspices of TARBA. Next one. Next slide. And like I said before, we added this to our spec that the contractor has to submit a QC plan for the production and placement. They have to provide a written certificate that no demolition waste. They also have to do water soluble sulfate testing. So it has to be every 1,000 tonnes and it can't be more, the concentrations can't be greater than 5,000 micrograms per gram. Next slide. And just to talk about that again, where we want, that's part of our acceptance. They have to submit the quality control plan and document how they're going to control that in their processes. Next slide. And just as final slide, we recommend a project startup to actually go to the site to confirm how they're doing it, confirm the designated stockpile is used, and then ensure the trucks are properly loaded to reduce segregation issues. Next slide. Okay, thank you. That's any questions?
Thank you, Rob, for the very good overview. And for getting into the detail there of how you managed everything from the phases and the testing to the quality control on the back end there. There was a couple questions in the chat box about your quality assurance plan or program for the RCM. I think you touched on that. Anything else you might want to add to that question?
Yeah, it's in our spec, so quality assurance. So we do the testing, and the key thing was staff were afraid to use it before, but now we have something to go to the contractor and say, hey, look, here it shows it's failed. Take it out or don't bring any more. 5 years ago, we had nothing to defend ourselves to say this is poor quality or not, but now we do.
Perfect. Joanne, any other questions to bring forward?
Yeah, I'm starting to see, the city of Toronto really leaning towards those outcomes-based kinds of specifications, and really seems like putting the onus on the supplier to meet the quality control specifications of the city of Toronto. So was there much interplay between, I know you guys probably let out these RFIs or set out the terms of these tenders, but is there a role that you play directly with procurement, or do they support this function as well?
Yeah, they support it. I mean, they're kind of not involved because we just specified in our tender documents. And
so no risk flags by them. No,
not at all. No.
Terrific. Thanks.
A question from another Rob with respect to, did the city have discussions with the aggregator concrete suppliers with respect to what you were trying to achieve and the challenges that you run into in order to get their insights?
Well, actually, they came to us back about 10 years ago, or in 2013, 14, because they came to us and say, look, this is TARBA, Toronto Area Road Builders Association. They said, look, we do all this work for you. We remove all this sidewalk, curb, gutter. We've got piles of it sitting at the airport. How do we bring it back into Toronto, doing work? So that's how the discussion came. Okay, if we want to bring it back, we got to ensure that you're doing it properly, that the product you're producing is going to meet what we think it's going to meet. So that's how this whole discussion started with, they actually came to us, and that's how it started, and that's how we built up the specifications.
Interesting. Thank you. Last question, and then it's time to pivot to some deep dive group discussion. So how did CBR or resilience modulus testing compare with virgin aggregates? Can you share a little bit of that?
I don't have that offhand. It's been a few years, but I had that slide. But I believe it was okay. I'll have to look back in it, but I don't know off the top of my head. So.
Are you open to people reaching out?
Yeah, no problem. Yeah.
Questions. Perfect. Wonderful. All right. Thank you very much, Rob. Appreciate your time, and hope you can stay and join for the discussion here. So pivoting to the sort of last portion of our agenda here. Thanks very much for all the context setting to help provide us with some insights that we'll need for going into these breakout group discussions. We have 5 groups split between our facilitators, and we have a guide essentially with some key questions that our facilitators will use over the next 60 minutes that we'll dig into with everybody here. So these will be managed by the facilitators, but before we head off into the breakout discussions, I wanted to just cover a few quick rules of engagement. I think most of you have changed your name in Zoom to make sure you have your first and last name, but that will help make sure we can identify you in the breakouts. We will invite you to unmute yourselves and share your insights and your thoughts in line with each of the questions. So turn on your camera and be part of the conversation if you're comfortable with that. You can also use the chat box as needed to provide some links or further information, and just encourage you to be really brief and to the point and specific wherever possible. be respectful, obviously, of the ideas and opinions of others, so that we can share openly, and feel free to challenge ideas, but not the individual. We'll also be audio recording the breakouts just for note-taking purposes, but we'll delete those afterwards, and we'll follow sort of Chatham House rules where you can use what you've learned through this session, but please no attribution to individuals or their organizations outside of the workshop. And we'll be putting together a short summary from all the plenary and breakout room conversations to share back with participants afterwards. We've tried to give a little bit of a mix in the different breakouts, but tried to keep you kind of within certain province or regions, or with a mix of academic research and government and other perspectives from industry. So without further ado, welcome you to have Matthias split us off into our breakouts, and we'll see you in about 60 minutes. So we'll come back to plenary at about 20 after. Thank you. Thought we could just do a quick round from the facilitators with 2 or so key takeaways or insights that you drew from the breakout discussions that you thought were particularly insightful, or the messages that you took away as being most important for that. So I might just call on our 4 other facilitators and ask them to share a couple points, and maybe I'll start because I see Jody on my screen here. Start with you, Jody, if that's okay.
Yeah, I took a lot of notes. So I think, what I heard, at least in regards to question 1, is that there's a lot of different standards, especially in Ontario. So you have the Ontario standards, but then the municipalities can amend those standards and use their own. So that's a very, I guess, big issue for industry in order to get increased recycled aggregates. I think in terms of barriers and opportunities, recycled or base and sub-base is the biggest opportunity for recycled aggregates. And then there seems to be agreement that a national standard would be ideal, and that an outcome and performance based approach would be very much welcomed.
Interesting. Joanne, do you want to add to that from your group?
Yeah, happy to just pile on, but with not to duplicate. So in our group, we had Monique from the province of Ontario, certainly. So that standard we heard in our research and also in our discussions today that is one of those standards that particularly municipalities in Ontario point to. We did hear that even though there's allowances, there's not a requirement. And then without any sort of tracking and reporting, it's really difficult to know if that specification or allowance is actually being maximized or utilized. And I get just sort of walking backwards for a second. I don't think these allowances are considered standards per se. We did ask the question, we did recognize that allowance that's pretty commonly used in Ontario is probably better than a decade old. Even that from that perspective didn't know, is that still, 30% still the right number. I think in terms of, what the barriers, it always comes down to QC, quality control, and whether it's a perceived barrier or a real one. There's still those lagging, maybe case studies that didn't go so well. And that goes back to the quality of the inbound materials, the product that's being used. That was very consistently echoed.
Yeah, we certainly heard that in our room in terms of, the quality concerns and the the capacity of some local governments to do their own testing isn't there, and that they've had all kinds of things in the past that have contaminated the supply. So there was a bit of a discussion around if you were to set up sort of a certification process for the facilities and the supplier side, how do you, who would manage that? How would it be set up? What would it certify? Is there an ISO standard that doesn't exist today that could come in the future? And also the challenges of local governments and others to procure in their bids, without a certification or something to point to, that it's challenging for the procurement folks to evaluate anything other than cost or some of the other specifications. So that's something to consider how you handle it, and that with you can raise the limits within specifications and different base layers, but without dealing with the quality issue, there's still going to be some hesitancy, I'd say, in terms of its greater adoption. Maybe I'll pass it to Ben next. If you're online, Ben.
Thanks, Paul. Yeah, so echo a few things that have already been said about the capacity of smaller municipalities without the same sort of engineering and procurement expertise. Some examples of where big cities are using it in their own operations, but not in contracted services and not in surrounding areas outside of their municipality. Some of the the challenges that were talked about were that virgin materials are getting harder and harder to source. So there's more of a business case for recycled material. And the challenges in the durability, not necessarily the strength. And then when we talked about quality control, we talked a lot about standardizing different stages of the process, specifically the crushing, and iteratively using some of these materials and testing them out in low risk applications before trying to figure it all out before we get started.
Those are great insights. Thanks, Ben. Mike, are you able to share a couple points?
Yeah, I'll try to share a couple of additional points. We had a lot of knowledge in our breakout groups, and a lot of the points that have been mentioned by others were mentioned. I guess a couple of the other things that came up, one at the very high level, almost an infinite scope for making more use of these materials if we get some of the market signals right, some of the standardization right. So that was really reassuring. A couple of the points that came up that haven't been mentioned as much yet. Sometimes the issue around quality is more a perception issue than an issue in actuality. So how do we create the belief based on the evidence that the quality is actually there, and work that through to both the technical municipal staff, some of the supply organizations, and even the public in general, that this will deliver as high a quality product. The other thing that came up that I found quite interesting is, while often the short-term economics or the project-by-project economics can be a lot depends on where you are. Sometimes it's cheaper, sometimes it's more expensive. But if the municipality does more work projecting out the long-term, some of the long-term economics, especially around dwindling supply of virgin materials and having to go further afield for virgin materials, the short-term economics become significantly tipped in the favor of recycled materials. And then the other one that I don't think it's been mentioned, but it came up a lot in ours, is that the role the suppliers can play in developing the best practices and doing some of the front stage of quality control, and then the municipalities come into the tail end to do quality assurance, quality control oversight on that.
That's great. I like the insight there, Mike, in terms of the cost considerations and getting a little bit more information. That could also probably apply to some of the GHG benefits that would also be considered around that. So thank you very much to all the facilitators. Just as we wrap up and next steps here, I just want to pass it to Joanne to help us close with a couple of points around how we see this going as the next step and the outcomes from this work.
Yeah, thanks very much for that. Again, a large welcome to all of who stuck with us today. We're going to be taking away all of the salient points and all of the key areas of discussion today and grinding through them. I mean, I think ultimately we had heard that, I think that a national standard, especially when there is low risk, high gain areas across the province or across the country, is possible. I think there's an appetite for that. We've heard that in our pre-workshop interviews, as well as the discussions today. So we are going to think through what that might look like. It sounds like there's a two-pronged, there's two parties that need to be part of this, certainly governments across the levels, but also the suppliers to the earlier point today as well. So we'll leave this workshop and probably re-invite you back to a meeting in short order, and maybe even start to put in front of you, what does an outcomes-based standard look like, or an outcomes-based specification look like, where we're driving, we're not mitigating the performance that's necessary of this application, but really trying to within it maximize the use of recycled aggregate. We heard very loudly, and one of my main takeaways today was that we may be using it more than we think, and we're not tracking it. So, and those tracking and reporting mechanisms, if we do that better, we might actually surface that we're doing this quite well and quite successfully, and we've got great case studies, and we don't have to go back to those failure ones, and that might help us give us confidence to move forward. But certainly our goal is to derive an outcomes-based standard so that we can help procurers and the engineering functions of municipalities as a first stop move forward with maximizing it, so, and harmonizing it. So that's the plan. We'll be in touch more with that.
Yeah, so thank you very much again to all the presenters and obviously our volunteer breakout facilitators for helping to make this workshop a success, and also for all the participants, as Joanne said, who stuck around and really shared your input in the breakout discussions and helped us kind of have some back and forth dialogue there. We will be getting a summary document from today's workshop, which you'll get in a couple weeks, and in the short term we'll also send you the presentation slide decks from the speakers if that's helpful. I also just wanted to quickly flag, there's a couple additional upcoming events you might be interested in. On March 29th and 31st, we're going to be doing a two-part virtual event and workshop with the CSA group on the sidelines of the Globe Forum in 2020 Globe Forum, and that's going to be essentially an event to convene stakeholders on the bigger picture of how do we move towards a more circular built environment in Canada, and potentially the things we need to focus on that would help set us up for a bit of a circular roadmap. So we've been very focused on one aspect of circular economy today, but thinking about the bigger picture across the whole value chain. And I also wanted to invite Rita to speak for 30 seconds or so about the upcoming National Zero Waste Council event on RAP that I mentioned earlier on will be coming up in April. Rita, are you still online?
I'm here. Thanks, Paul. Yeah, great conversation today, and it's great to see the link between the two. I think, for folks that are interested, we're holding in April a session very similar. We're going to focus specifically on asphalt, but it will be great to see the connections between, the summary document that comes out of this event, which I'm really curious to see. Our event on the 20th, as I said, will focus on recycled asphalt, and we'll hear from folks at Richmond, where it was mentioned earlier today, there's been some really interesting work on recycled asphalt there, 40% RAP pilot. Lafarge will be there as well. Good Roads as well will be joining us to present on their research, which was mentioned today. So I'll leave it at that. I think there'll be a lot of connections, and I think all of this work is so critical. So it's great to see the conversations today were really interesting. Thank you.
Will you be sending us information about that forum?
Yeah, I think I'll try to connect with Paul on that, because I recognize we won't have all of your contacts, but I would love to link these. I mean, I think they're very similar. They're complementary events. So I've got your name, Chris. Thanks.
Yeah, we can send the registration link out in a bit more detail to everybody when we send out the summary.
Good.
Thanks, Paul.
Okay, well, thank you again. Please reach out to myself or Joanne here, contact information if you'd like to continue engaging with us on this topic. And that concludes today's virtual workshop right on time.